Hello, welcome to our senior project. Over the last few months, our team has been working hard to solve the problem of object detection in visually degraded environments. This is for the class CS 426 at the University of Nevada, Reno for our senior project in our computer science program. On our team, we have Dustin Barnes, myself, Jack Currie, and Brenda Penn. Our external advisor is Dr. Kostas Alexis of the Autonomous Robotics Lab, and our instructors for this course are Sergiu Daskalou and Devrin Lee. Now, we hope that you are as excited as we are for the autonomous future that's coming. The possibilities are endless. Pretty soon, instead of driving, you'll be able to lounge in the back of your car with a loved one, maybe enjoy a nice book, or, even just let Baxter take the wheel. But before these thoughts are realized, there is still much work to be done. You see, right now we have a long tail situation. While many of the situations in which self-driving cars will be expected to operate in have already been technologically figured out, such as driving on a predictable freeway on a clear, sunny day, there is still a large number of conditions in which they do not yet work, such as driving at nighttime, or driving in inclement weather conditions, or unpredictable and chaotic roadways. We are making a contribution to the problem of driving at night. Specifically, we're addressing the problem of detecting where other vehicles are on the roadway at nighttime. To understand what we'll be doing, you'll first need to understand the difference between object classification and object detection. Object classification is simply the problem of determining whether or not an image contains a certain type of object. Object detection, on the other hand, is the problem of actually locating where different objects are in an image. For example, on the background image here, where are the cars versus where are the trucks? Being able to detect where other vehicles are from visual data is something that we humans take for granted, but it's something that we need to teach computers how to do. It's one of the first steps for vehicles to be able to truly understand their surroundings at nighttime. So how are we going to do this? Well, there are three main steps. One, we need to collect data of roads at nighttime. Two, we need to clean, label, and pre-process the data. And three, we're going to use machine learning to train a neural network to perform the task of object detection using this data. So, for the task of collecting data, we both use roadside cameras and car-mounted cameras at nighttime. From these cameras, we extracted video onto our computer. And from this video, we extracted the individual frames for the images. For the second step, we needed to pre-process these images and clean them. A lot of this entailed actually labeling the data, where we put bounding boxes saying where the vehicles are in each of the images. We used MATLAB in order to perform this labeling, from which we got our data. And once we had this data that was labeled, we used some data augmentation methods in order to create more generalized images that we could use. The last step is to train a neural network. A neural network is essentially a statistical model which looks something like this, which you need to show a large amount of real-world data and train it to perform specific tasks. In our case, the task is that of object detection of vehicles at nighttime. To create our neural network, we use popular open source libraries Keras as well as TensorFlow. While our neural network is still in the process of training at the time of making this video, it will in the future be integrated into the backend of the user interface component of our program, which my colleague Dustin Barnes will demo momentarily.
Here's a sample of the user interface in action. We have options to load a pre-recorded video and then perform analysis on it, or to analyze a live feed from a webcam. However, there aren't many vehicles to identify in an office environment. For this demonstration, we'll be performing analysis of a video in daylight conditions using YOLO, a state-of-the-art object detector. This analysis does take some time, so we'll be cutting briefly here while the analysis is performed. Now that the video has been analyzed and loaded into our player, you can see that while YOLO can identify some cars under optimal daylight conditions, there's still some work that needs to be done. Next, I'll be showing a video that was recorded during nighttime conditions. As you can see, YOLO fails to identify a vehicle that is plainly obvious to human eyes, and this demonstrates why research such as ours is necessary for the future development of autonomous vehicles. We hope you've enjoyed our video and learned about the challenges of computer vision in autonomous vehicles.
Thanks for watching.